Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is integrals. In this video, we'll be focusing on solutions to previous year questions which have come in CBSE board exam. The first problem we need to evaluate the integral this. We'll be using the property e power a log x is equal to x power a. This is the property of log. So we'll use this in this equation. So e power 9 log x will be what? X power 9. Power 9 minus x power 8 divided by x power 6 minus x power 5 dx. So we can take say x8 common. So this will be x minus 1. Similarly, this will be xy common, x minus 1 integral dx. So this will get cancelled, we will get x cube integral dx, which is x power 4 by 4 plus c. So option C is correct. Now in this problem we will put e power minus x equal to t implies minus e power minus ex dx equal to dt. So we can write the integral as minus dt by 16 plus 9t square. But we know one formula that I will tell you just that dx by a square plus b square x square is equal to 1 over ab tan inverse bx by a plus c. So we will be using this formula. Here a will be equal to 4, b equal to 3. So we will get I equal to 1 over ab. So minus is already there, minus 1 over 12 tan inverse bx. So 3 bt. So this will be bt, which is 3t, but t is e power minus x. So 3 e power minus x by a is 4 plus c. So let us check which. So option B is correct. For a function which of the following holds true? From the definite integral property, this is correct. But let us have a look at other options also. Minus a to f of x is equal to if f is an odd function. So this should be odd. So this is not correct. Similarly, this they are given equal to f is an odd function. This is wrong. For an odd function, this is equal to 0. Similarly, this is also not correct. So the correct choice is A. So in this problem, generally we write in the form of partial fraction. So we 3x plus 1 by denominator x minus 2 the whole square. X plus 2 can be written as a by x minus 2 plus b by x minus 2 the whole square plus c by x plus 2. So this can be written as 3x plus 1 a into x minus 2 x plus 2 plus b x plus 2 plus c x minus 2 the whole square. So we can put x equal to 2 here. Suppose we put in this expression x equal to 2, then this term will vanish and also this will vanish because 2 minus 2 is 0. Here also 2 minus 2 will be 0. So if x equal to 2, this will be 2 plus 2 4, 4b. 4b equal to 3 into 2 6 plus 1 7. So b will be equal to 7 by 4. Similarly, we can easily evaluate a and c. So a and c I have done it for you. So a will be equal to 5 by 16 and c equal to minus 5 by 16. So we can just now put it here and evaluate the integral. So I will be equal to a is 5 by 16. 5 by 16 integral 1 over x minus 2 is log x minus 2. Now we have b. b is 7 by 4. 7 by 4, and for x minus 2 the whole square, the integral will be 1 over x minus 2 with a minus sign. So 1 over x minus 2. C is minus 5 by 16 log x plus 2. So from these two we can easily write 5 by 16 log x minus 2 by x plus 2 minus 7 by 4 x minus 2 plus c. So this is the final answer. In this we make the substitution a power x equal to t. Then what is the derivative of a power x? A power x log a dx equal to dt. So ax dx, we want ax dx. So that will be equal to, implies ax dx equal to dt by log a. Whenever we don't put any base here, it is meant that it is a natural log. So always log a means log a to the base e. When we are not writing anything, default is to the base e, which is natural log. So we will now put the integral becomes 1 over log a, 1 over log a, integral dt by square root of 1 minus t square, which is 1 over log a sine inverse t, but t is a power x plus c. So the correct option is A. So again this problem will make it partial fractions. We can write this as a by x minus 1 dx plus, since here square term is there, we can write bx plus c divided by x square plus 4 dx plus, okay, we need to find a, b and c. So we can again take LCM and we can get x equal to a into x square plus 4 plus bx plus c into x minus 1. This is equal to x. So we can make substitution such that one term becomes 0. So if we put x equal to 1, when we put x equal to 1, this term will vanish. 1 minus 1 is 0 here. So this will be a, 1 square is 1 plus 4, 5, 5a equal to 1. So a will be equal to 1 over 5. Similarly, we can get b and c. b will be equal to minus 1 over 5 and c equal to 4 by 5. Now we put it here and find the integral. So this integral I will be equal to a is 1 over 5, 1 over 5, and x minus 1 will be log x minus 1 integral plus bx by x square plus bx is minus 1 by 5 minus 1 over 5. We will just put the integral x dx by 1 plus x square, I'm sorry, x square plus 4, x square plus 4 plus c. c is 4 by 5 plus 4 by 5 integral dx by x square plus 4. So how do we do it now? This we'll write as it is. First one, 1 by 5 log x minus 1. Now what is the integral of this? If we put x square plus 4 equal to t, then this will be 2x dx equal to dt, and this will be dt, and 1 over 2 will come down and we'll get log t. So this will be minus 1 by 5 into 1 by 2 log t. So log t is x square plus 4. And what is the integral of this? This will be a square plus x square, which is 1 over a tan inverse x by a, plus 4 by 5 into 1 by 2. A square means a will be 2. So tan inverse x by 2 plus c. So we can get it now. We will write the final answer. 1 by 5 log x minus 1 minus 1 over 10 log x square plus 4. This will be 2 by 5 plus 2 by 5 tan inverse x by 2 plus c. This is the final answer. So we will use the properties of definite integral to solve this. So we can write this as 0 to pi, pi minus x sine pi minus x by 1 plus cos square pi minus x. So this will be equal to 0 to pi, pi minus x. This will be sine x by 1 plus cos square x. So this we call it as, say, I only. This is also I and this is also I. So we'll add these two. So this will become 2i. 2i will be equal to this minus x sin x is there here plus x. So that term will get cancelled. Only pi term will remain. So pi sin x by 1 plus cos square x. We see that from this expression, now x is gone in this expression. So this is much simpler to solve. We'll put cos x equal to t implies minus sin x dx equal to dt. So when x is equal to 0, when x equal to 0 here, t will be equal to 1. When x is equal to pi, cos pi is minus 1, t will be equal to minus 1. So we will get the expression 2i equal to pi. So instead of 0 to pi, we will now put integral 1 to minus 1. Yes, 1 to minus 1. And this will be 1 by 1 plus t square dt by and minus sign also will be coming because this is minus sin x dx. This is equal to minus pi tan inverse t 1 to minus 1. We can remove this minus 1 and change the sign. So this will be tan inverse minus 1 to 1 and 1 pi will be there. And here 2i is there, so I will be equal to pi by 2. So tan inverse 1 is pi by 4. And minus 1 is minus of minus pi by 4. So this is equal to pi by 4 plus pi by 4 is pi by 2. Pi by 2 into pi by 2 is pi square by 4. This is the final answer. This problem again can be written in partial fraction form. So a by x square plus 2 plus b by 2x square plus 1. So we can write x square plus 1 equal to a 2x square plus 1 plus b x square plus 2. So we can compare the coefficients. So this will be 2a plus b will be equal to 1. Similarly, a plus 2b, a plus 2b equal to 1. So if we solve this, we will get a equal to 1 by 3 and b equal to 1 by 3. We will put it in this equation and get I equal to, this is I equal to, a is 1 by 3 integral dx by x square plus 2 plus 1 over 3 dx by 2x square plus 1. So we know that this is again a square plus x square form where a equal to root 2. Similarly, this also is ax square plus b square form. So this also can be easily known integrals are there. So we'll just write equal to 1 by 3 into 1 by root 2 tan inverse x by a x by root 2 plus 1 by 3 into 1 by a tan inverse ax root 2. So this is the final answer. So in this problem, we write tan x by sin x by cos x. We know sec x is 1 over cos x. This is sin x by cos x. So if we simplify by putting this, we get the expression 0 to pi x sin x by 1 plus sin x. Now we use the property of definite integrals. This will be 0 to pi minus x. Sin pi minus x is sin x only, divided by 1 plus sin pi minus x, which is sin x only. So if we add this and this integral, the x sin x and minus sin x part will vanish, only pi will be there. So we can write 2i because we are adding these two integral and this is equal to I. This will become 2i. 2i will be pi integral sin x by 1 plus sin x dx 0 to pi. So I will be equal to pi by 2 and this can be written as 1 minus 1 by 1 plus sin x dx. So I will be equal to pi by 2. What is the integral of 1 dx is x itself. This will be x minus integral of 1 by 1 plus sin x is tan x minus sec x. You should be able to do this. This is not difficult. Integral of this is this term tan x minus sec x. Limit vary from 0 to pi. So we can put pi here. This will be pi by 2 pi minus 2. You can put these terms one by one and get the answer. So this is the final answer. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.